Hey guys, I'm sorry I couldn't be there for your review today due to a doctor appointment, but I definitely think that this is going to benefit you to have a video to be able to listen to different parts a few times over if you're having trouble with a certain section. So the test is pretty similar to the questions that I'm giving you today. Obviously there's different scenarios and everything, but if you do well on this review, then you can definitely expect to do well on the test, okay? So the first question says, a sample is being chosen for a survey to find out how people feel about doing or adding more stop signs near a school. Which group would be the least biased? And if we're talking about that word biased, it means that they are leaning one way or another, that they have an opinion about it already. And so there's a couple different choices here. They're all randomly chosen, so that's not going to help us to determine the correct answer, but we've got voters, drivers, students, and teachers. So go ahead and take a minute to answer this yourself. Pause the video if you need to, and then I'll talk through it. So I'm going to look at the question one more time, and I notice that it's adding more stop signs near a school. So I think that there's going to be people who have an opinion about it. I'm thinking that if they're drivers, then they're certainly going to have an opinion about things. And the students and teachers belong at the school already. So I think that the only way that you could possibly find one that is the least biased would be these voters here. And that's because they could be drivers, non-drivers, they could be kids, or I shouldn't say kids because they're voters, but they, not drivers, but they can be men, women, they could be teachers. If it's at a high school, it could be some students if they're over 18. So it's the least biased group of people here. So your answer would be A. Okay? And the second question says, which of the following is a random sample of shoppers at a grocery store? So we know that they're going to be at a grocery store, but we're looking for that word random again. The first 10 mothers who come into the store, every person who visits the dairy section, every fifth person who enters the store, or 20 people who go through the express lane with 5 items or less. So think about it for a couple minutes. I hope you already actually completed this and you're just actually using this as a check for your answers. But if you haven't, go ahead and take a minute to answer it. And looking at this, I'm going to go through each one. I want random, and they're shoppers at a grocery store. So the first 10 mothers who come into the store, they're definitely going to have opinions about things because they have kids. So that's not very random. That's looking for a particular type of person. The second one, every person who visits the dairy section, and that could be biased because there might be some people that are not in the dairy section. Maybe they're just coming in for something like they needed some fruit for the day, or maybe they forgot something for, and needed to stop at the deli or something. So you would not have a fair chance of everyone getting picked for that. Which leads us to number 3. Every fifth person who enters the store means that everybody has a fair shot. It doesn't matter what they're shopping for or what they're there for. Every fifth person means that everyone has an equal chance of being chosen for it, because all they have to do in order to qualify for this is walk through the store, and then it's kind of like picking out of a hat for the every fifth person. And then the last one, 20 people who go through the express lane with 5 items or less, that's biased because it means that it's only people who are in there for a quick thing, and so it could be, if I want a totally random sample, then every fifth person who enters the store would be the best answer, okay? So again, for this question, I hope you answered it already. It says, Matt and Nate want to know which video games people prefer at an arcade. They had different ideas on how to choose their sample. So Matt's idea was, I will ask the first 15 people who play the crane game, and Nate can ask the first 15 people who play skee-ball. And then Nate's idea was saying we should ask every 10th person who comes up to the cashier to put money on their game card. And so looking at these two, I'm sure already you have your idea based off of all of our conversations in class, but whose sampling method is better? Which one is the better method that is looking for a non-biased sample or random sample? And that would be, ready? Nathan, or Nate. And the reason why Nate is better, because it's a random sample, okay? Because everyone has to add money to their game card at some point. So whether you bought it the first time or you're adding more money on it, but anybody who's playing at an arcade has to get the card. And because everyone has to buy a card, so I would add all that. Everyone has to add money at some point, right? Has to add money. And I would also that's a shortcut. Write the word money for yours, okay? For Matt and Nathan, or for Matt is only choosing people who like the skee ball or the crane game. Skee ball, crane, and so they could be biased, right? If they're standing there, then chances are, oops, I'm sorry. If they're standing there, then chances, I'm doing it again, then they would be biased for those two games if they're in line for it, right? To survey their sample, Nate poses the question, do you like Pac-Man best? Determine whether or not the question is biased and explain. We talked about this in class the other day, and yes, this is biased because, you remember why? Because they suggested a game, right? And so what would be a better way to say it? Okay, so here's the answer. It's yes, it is biased because a game was suggested, right? So instead, your actual answer should say what he should have said. And what he could have said is, what game do you like best? Or what game do you prefer? Or anything like that. Just leaving it open-ended, okay, so that they do not have any sort of bias in the question. But definitely give a sample question that they could ask when you're saying that somebody did something wrong. Always give an answer option for them, okay? So the next one. In a random survey of 50 students at Ryland Middle School, 32 said that chocolate was their favorite flavor of yogurt. The school has 450 students. How many of them are likely to select chocolate as their favorite flavor? So we talked about these kinds of questions before. We had two different kind of ratios going on. We had the sample, right? And we had the whole population, like all of them put together, right? So in the sample, we have the part and the whole, and the same thing with the population. We have the part and the whole. And so this is the whole big group, and this is like these little groups that we're pulling out of it, right? And so we want to set a ratio that is equivalent to both of them. So in this case, a random survey of 50 students in Ryland Middle School, that's the sample because it's not all the students. The population is everybody, okay? So out of those 50 students, 32 said that chocolate was their favorite. So for our sample, we have 32 out of 50 like chocolate. And going over here, the population of the whole school is 450 students total. And so since that's the whole, it's going to go in the denominator, and we're going to set these two as equivalent ratios to each other. So I ask myself, what did I do to 50 to get to 450? Or you could ask the other way, what is 450 divided by 50? And what I did to 50 is I multiplied by 9. And so whatever you do to the bottom when we make equivalent ratios or equivalent fractions, you do to the top. And if I do that multiplication, which you're going to do on a calculator and I just did with Google, you're going to get our missing number is 288. So make sure that you say that 288 students are going to select chocolate as their favorite flavor. So 288, and make sure you put that label in there so you get full credit. And make that answer statement. I don't have enough room on this right now, but make sure you write that answer statement so that you get full credit, okay? So if you didn't remember how to do that previous problem, this is a really good follow-up because it's pretty much the same procedure. It says there are 2,300 licensed dogs in Clarkson. A random sample of 50 of the dogs in Clarkson show that 8 have ID microchips implanted. How many dogs in Clarkson are likely to have microchips implanted? So I've got to go back to that sample, right? And the whole and the part in the whole, and then the population. So how many are in all of Clarkson, okay? How many can we expect? And so it just means that we are going to continue to assume that this ratio that they have is going to be the same throughout everything. This is just a guess, okay? So in my sample, I had my part was 80 out of 50. 8 dogs, 8 out of 50. 8 out of 50 dogs ended up having microchips, okay? And in the population, I have 2,300 dogs. So I'm going to set up an equivalent ratio, an equivalent fraction, to find out what is my missing number. And this number right here will tell me how many dogs I can expect to have ID microchips implanted in them in all of Clarkson. So I asked myself, what did I do to 50 to get to 2,300? And so I'm actually going to divide 2,300 by 50, and it's 46. Whatever I do to the bottom, I do to the top, times 46. And the answer is 368 dogs. All right, so 368 dogs should have a microchip, right? Now, this is a question that's in the same vein of everything else, but there's a little bit of a trap to it, and because you don't know how many are in the sample. So when we have a sample, you have the part and the whole, right? And the same thing with population. You have the part and a whole, part, whole, part, whole. Okay, but this one's a little bit tricky and you have to think about it for a second. So there are 1,500 fish at the aquarium store. The results of a random sample of fish at the store are shown in the table. And there's 32 goldfish, 16 tiger barbs, and 12 angelfish. And so it says estimate the number of each type of fish at the aquarium store. So the only thing that I know right off the bat is my whole over here in the population. I know that this is going to be 1,500, right? And I'm actually going to have to do 3 separate problems for this. I'm going to have to work on the goldfish, the tiger barb, and the angelfish. So I have 1,500 over here. I don't know this number. And for goldfish, I know that we have the 32 is the part, which is the confusing thing. Because I don't know the whole of the sample yet. In order to find that out, I've actually got to add all of these numbers to find out how many fish were actually randomly sampled as my whole. Okay, so it's not very complicated, but out of the sample, 32 were goldfish, and I've just got to find out, okay, how many total were taken. So what I do is 32 plus 16 plus 12, which is 60. And then I ask myself, okay, what did I do to 60 to get to 1,500? And everything else is repeated from the other problems that we had so far. And so using my calculator, I know that 60 times 25 is 1,500. And so I do the same thing up here, 32 times 25. 32 times 25, and the answer is 800. So there are 800 goldfish in the aquarium. So now I'm going to move over to tiger barbs, and I know that there's 16, and now my work is done. I know that the whole sample out of the 3 types of fish were 60, and over here I know that it was out of 1,500 total fish, and so I asked myself what was the relationship between these two, and this was times 25. My work is really easy now because I just have to keep on repeating it because nothing changes with the wholes. The only thing that's changing is that part of the sample for each one of the type of fish. Okay, and so I asked myself, what's 16 times 25? And the answer is, which is 400. And then I do the same problem over here, and I do 12 over 60 equals 1,500 over my unknown, right? And so I know that I've got to multiply times 25, and 12 times 25, which is 300. And I should know this actually because all of my fish should equal 1,500. That was my total in the beginning of the problem for my population, right? And so 800 plus 400 equals 1,200 plus 300 is 1,500. So I know I got my answer correct. If these numbers do not add up to the population, the whole population that you were given, then you did something wrong in the problem and you should double check your work, okay? Make sure you're using that calculator. It's a really simple problem. The only thing that's different about this one is you've got to find out that whole population first, okay? These problems are also really kind of easy if you get the hang of it and listen in class. And it says, in a recent shipment of headphones, 25 were defective. The manufacturer generates a random sample to simulate 20 headphones in the next shipment. The integers 1 to 25 represent defective headphones. So we did examples of these in class, not so shabby. All we have to do is we have to look through all of these numbers and look for how many of these numbers are the numbers 1 through 25. So looking at that first row, I don't see any of them. Second row, the 19 pops out at me, and the number 5 pops out at me, and that is it. So we definitely got a couple of extra numbers up here in this problem that we're just going to have to ignore. So I've got to ask myself, what's in my sample, right? How many? We're looking at how many headphones were defective, and this is my sample right here. So my part of my sample that was defective was 2. And my whole of my sample were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 20. Just wanted to double check. I thought it does say 20 headphones in the next shipment. So this is our sample. And now I want to kind of guess what's going to happen when the whole population is accounted for. And so, based on the sample, how many defective headphones might the manufacturer expect in the next shipment of 5,000 pens? That's funny. It should be headphones. The question on the test says pens. So there's your little hint there that it's a similar problem, different numbers, but so don't get hung up on the numbers right now, but it should be headphones. Okay? All right. So, looking at this, you know what you're doing at this point. You're going to ask yourself how many times does 20 go into 5,000? And your answer is 250. So, we're going to multiply this by 250. That means we're going to do the same thing up here. And 2 times 250 is 500. So 500 headphones 500 headphones might be defective, about 500, right? The answer is 500, but I just want you to understand that this is a simulation. This isn't like real life. This is just like how many can they expect. And 10% of their headphones being messed up is a large number. So if a company gets this information, they're going to definitely want to do something to help themselves out, right? So moving on, here we go. So here's our first box plot that we have to take a look at. It says the data set shows the number of items each person checked out of the library. So they give us all the numbers, and it says make a box plot to display the data. And so the nice part about this test is we're just giving you exposure to something like this, and so they even tell you what you should have included. Isn't that really nice? The one thing that we don't tell you on the test, though, is that you need to order the numbers from least to greatest. So make sure you remember that, because that will not be a reminder on the test. So if I do that, I have the number 1, 2, how many 2s do I have? 3. 1, 2, 3, 4. 4 2s. And then I have 3 3s. 3, 3, 3. And then I have the numbers 2 6s. 6, 6. And then I got to squeeze in a 13 over here. Okay? So, got all my numbers. Let me double check how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. That's an important check step, so that you don't get yourself lost in the middle of anything, okay? So in order to do a box plot, you're always looking for the medians. Please, please, please look for the medians, which is the middle number. You don't have to do any major calculations. All you're doing is looking for that middle number. You might want to cross off numbers as you go lightly, and go back and forth until you get to that middle number. And in this case, it is a 3. So that is my median for the whole data set. So I'm going to go ahead and put a dot at the 3. And remember, this is my median, and that's where I put the line through the center. Don't forget, I also have to put in the lowest number, which is 1, if you want to, with the whiskers and everything. You know what? I'm going to do that last, so I don't get confused. So if that's my middle number here, I'm going to now take this data set, and I'm going to look for the median in here. So I like to go and cross off a second way, go back and forth, and my median is 2. Okay. And that's my lower quartile. So that is also going to have a dot with a line through it. And then I'm going to find the median of the numbers up here in the upper quartile, and it is a 6. So I go ahead and I make my dot, put the line through it, and there's my box. And then for my whiskers, remember that they are the lowest number, which is that 1 that I just mentioned that I wanted to wait for. And my highest number, which is 13, which probably looks like it is going, like, it's obviously an outlier, right? But you see how that long arm is out there, so that long whisker is out there, which shows you what an outlier can do to your data, okay? So that is what your box plot should look like. And it says, for this set of data, one can make an inference that the number of library books that are checked out is likely to be 3 or fewer, exactly 13, less than 2, or more than 6. So this is where you, first of all, since it's on this test, nice that they actually have the numbers for you, so you could look at that. But if you were just using the box plot, if they didn't have that, we know that the median is the middle number. And so you know that it has to be that 50% of the numbers are on this side of the number 3, and 50% of the numbers are on the right side of the 3. And so this is the middle of the road. And so looking at this, it says the number of library books that are checked out is likely to be 3 or fewer. Since that is the median number, and no other options say that, so you can circle that number, because it is the median and it is included in that 50%. And it could have been repeated over and over and over again. But exactly 13 doesn't work because there's only one 13, and it's obviously not that's our highest value. Less than 2 doesn't work, and more than 6 didn't work. So because that was my upper quartile. So 3 or fewer is the best answer for that choice.